Today I'm going to talk about a cryptosporidiosis outbreak that I was involved in earlier this year, which affected human health, and how a One Health approach involving a multidisciplinary team helped control it and ultimately to protect public health. So I'm going to give a brief introduction to Cryptosporidium, including some figures on the prevalence in cattle and in humans. I'm going to talk about the outbreak investigation itself, so who was involved, who did what were the results of it, and finally the overall outcome, so what actions Public Health England might take in the future to reduce the likelihood of further outbreaks of disease linked to farm vending machines. And this includes not only cryptosporidiosis but also other pathogens which might be present on a farm, such as Campylobacter, E. coli, Salmonella, etc. So, what is cryptosporidiosis? So it's a disease that's caused by the protozoan parasite Cryptosporidium. There are over 26 species of the parasite, which have been identified in many mammals, birds and reptiles. Fortunately, not all of the species cause disease. Some of them are more restricted in their host ranges than others. There are 4 species that are found in cattle, but only one of them, Cryptosporidium parvum, is thought to cause clinical disease, and this is usually in young cattle, young calves less than 6 weeks old, and it is zoonotic. The parasite itself is spore producing, so it's protected by a tough outer shell that allows it to survive outside the body for a long period of time, which makes it very difficult to treat and very difficult to remove from the environment. As little as 10 oocysts can cause disease. An infected calf can shed billions of these oocysts, so you can see how infectious this parasite can be. Cryptosporidiosis is the leading cause of waterborne disease in humans, and that's either through exposure to water or contaminated feces. Exposure to water, that might be either recreational water such as a swimming pool, or it might be through drinking water. The clinical signs that we see in calves include profuse watery or yellow scour, resulting in dehydration, and then may progress to death. For animals that survive, there's been a study by the Moordun in Edinburgh which suggests that cattle that have had cryptosporidiosis as calves could weigh up to 30 kilograms less than their counterparts who have not had crypto by the age of 6 months. Which is, so it's a production limiting disease in that respect for the ones that survive. So a little bit about the number of cases that we have had. So this chart or table shows the number of cattle cases that we've had in APHA since 2012 to 2020, and you can see there at the moment we'd probably diagnose somewhere in the region of almost 300 cases per year in cattle. It looks like there's a very significant decrease from the last sort of 8-9 years, but actually it's likely to be an artifact. So the number of submissions over that time has probably dropped as well, and obviously there's other ways of detecting disease, whether it be penside tests or other labs who also carry out testing. So that's just an indication of the number of cases that we currently see within APHA labs. Seasonal distribution, so we can see here that there's a seasonal peak in the springtime, and that's associated with lambing and calving season. The herd type, so in the yellow we've got dairy herds, green is from beef herds, the lighter green is calf rearers, and then the red's unknown. So the unknown is purely the herds where we've had submissions where the information hasn't been provided to us. But you can see there that the dairy herds have got the largest percentage of diagnosis there, and that's just due to the management systems that dairy calves tend to be reared in. So moving on to people now. So this graph was taken from Public Health England website, showing the number of cases 2008 to 2017 in humans in England and Wales. And you can see there's somewhere in the region of sort of maybe say 5,000 cases per year that are diagnosed. So that's Cryptosporidium in total. So it's not just Cryptosporidium parvum. Apparently I don't have the data for 2020 and 21, but apparently the number of cases is significantly lower, and that's due to the effects of social distancing and less mixing due to the pandemic. So there's been less cases, there's also likely to be less visits to doctors, less samples submitted, etc. So the numbers over the last couple of years would be significantly lower. Seasonality in humans. So we can see here there's two peaks. So we have the first peak, which is the springtime peak, and that's associated with Cryptosporidium parvum, and that's due to increased contact with lambing, calving, open farms, etc. And then the second peak, the larger peak, is associated with Cryptosporidium hominis, and that tends to be associated with travel. So we get that peak in the sort of autumn time after people have been away over the summer. So you can see there usually hominis is there's a greater prevalence of hominis than parvum in the human population. However, apparently in the last year that has turned on its head, and we're seeing more parvum than hominis. And again, that's an outcome from behavioural changes, less travel, less mixing, etc., due to the pandemic. So moving on to the outbreak itself. So Public Health England, as they were at the time, they've since formed the UK Health Security Agency, but at the time they were Public Health England. They were informed of 3 cases of Cryptosporidium parvum in individuals that were not linked by family or by household, but they were geographically linked in that they were from the same area. In cases of GI infections, Public Health England have a questionnaire which they use to gather information from affected individuals. So they're asking about clinical details, onset of clinical signs, timings, etc. And they're also finding out things such as travel history, occupational details, what contact might the individual have had with animals, have they eaten out, what food exposures or milk exposures, water exposures, including recreational water, where did they do their shopping, etc. So they analyse these questionnaires, and this can identify potentially linked cases. So in this instance, there was a common exposure found between the 3 individuals, the individual cases, and that was consumption of pasteurized milk, which was bought from a farm vending machine in Somerset. So because of this common exposure, they then formed an outbreak control team to deal with it. So what's an outbreak control team? So it's made up, it's a multidisciplinary team basically, made up of individuals from various agencies and organisations who bring their own area of knowledge and expertise to the meetings, and in doing so can assist the investigation by providing advice or sampling data to hopefully prevent further cases. So the request for assistance comes from the Consultant in Communicable Disease Control, who is the chair of the outbreak control team. And it contains individuals from the public health bodies, so registrars, infectious disease consultant, epidemiologists. Then we have input from the environmental health team, which is part of local authority. We have disease specialists from the lab or reference units. APHA input, so that was myself, so I was a veterinary investigation officer involved in this case. And we may also have a veterinary advisor for One Health inputting into the case as well. Depending on the situation, if it's a dairy farm that may be involved, then Food Standards Agency might get involved via the dairy hygiene arm of the agency. And then depending again on the outbreak, the health and safety executive may be present in the form of a health and safety officer, but that will tend to be in larger outbreaks and where the risk is thought to still be ongoing. And again, we might have input from the farmer's private veterinary surgeon to represent the client and assist with farm management if necessary. So the outbreak control team meet to assess or to review the evidence that we've got. So it's a clinical evidence, epidemiological evidence, any microbiological evidence, and environmental evidence. So it's bringing everybody's knowledge from various visits that have been carried out, bringing it all together to review what we currently know. And that evidence contributes to the risk assessment. So we need to consider, what is the risk to public health? Is it an ongoing risk, or has it been reduced or negated already? Or if not, then what control measures need to be put in place in order to do so? We look at what further investigations need to happen. So if we don't have enough evidence to make that decision, we may need to do further sampling or visits to get that information. And then finally, to communicate that risk with and requirements with the owner or the operator of the business. You need to be aware as well with premises that are open to the public. So this wasn't the situation in this case, but if you had a petting zoo, for example, there might also be media attention involved in this. So you need to be aware of what information needs to be out there as regards protecting public health, but you also need to be aware of confidentiality regulations as well. Communications also can actually be a useful way of case finding. So alerting people to the risk, but also to look for affected individuals to come forward as part of the outbreak who may not have been identified so far. So my farm visit, so I visited as part of the APHA in my veterinary investigation officer role. So there's three main purposes of the APHA farm visit. So one is to take samples. We want to also gather information in order to produce an epidemiological report, and we want to provide advice as regards disease control to the farmer or the keeper. So starting with sampling. So the aim of the sampling is to provide microbiological data, which will hopefully complement epidemiological findings and link human cases to cases that we may have on the farm. So that's the main aim of sampling, rather than to just generate prevalence data, although it is useful to know the burden of disease on farm for disease control purposes. So in this case, I took 28 fecal samples, and you want to take these from either clinically affected animals, or if there are no clinically affected animals, then environmental samples from potentially implicated groups. So, for example, the young stock housing. These samples were screened by fluorescent antibody testing at APHA Carmarthen Lab, and any positives were to be referred to the Cryptosporidium reference unit in Swansea for species ID and genotyping by PCR. The timing of the sampling is really important. So as I said, it's younger animals that are affected. So immunity is age related. And so we need to get out there sort of as soon as possible, basically, in order to take the samples at a relevant time. Information gathering. So we carry out a farm visit to inspect the stock and the premises for cleanliness. We're looking at general husbandry, farm hygiene, anything which might increase the risks of human infection with cryptosporidiosis. We're looking at the sort of the contact potential. So do the public or any visitors have contact with muck heaps or soil pathways, contaminated footwear, any direct animal contact, such as bottle feeding or petting zoos, etc. And then we feed that information back to the outbreak control team and to the One Health team within APHA. And then finally, providing advice to the farmer or the keeper on sort of animal hygiene, husbandry, disease control. So there are two main ways of reducing the risk of cryptosporidiosis on farm. So one is to reduce environmental contamination, and the other is animal management techniques. So that would be sort of rearing calves in appropriately aged groups, not mixing them, isolating any affected animals, etc. As I did mention, it is a particularly difficult disease to control on farm. We also give advice about the consumption of raw milk. So in this case, the milk that was being sold was pasteurized. However, a lot of farmers and their family will consume raw milk from their own farm. So it's we provide advice to them regarding that as well. So the outcome of my visit, it was a really well-managed, clean, tidy, well-run farm. It had about 200 milking cows and 500 head of cattle in total. There's good biosecurity, so they didn't buy in stock, they didn't have any contact with neighbouring herds, and they didn't have any significant wildlife issues either. They had no ongoing herd health issues, and they did have regular input from the private veterinary surgeon. The results from the samples I took, so there was one positive result for crypto out of the 28 samples I took, and it was found to be the same unusual, apparently, subtype as the human cases. So we had that definitive epidemiological link there. The positive was from a 4-week-old calf, which was individually housed, and it wasn't clinically affected at the time of the visit. And there were no other clinically affected animals at that time. So the environmental health visit. So environmental health is part of local authority, and they're responsible for licensing the premises as a food business operator, and also for carrying out the sampling and any enforcement action if needed as well. So they ideally would visit on the initial approval, and then I think twice yearly for sampling. However, obviously due to COVID, there was a few delays in getting these visits done, I think. when they visited in February this year, they found that the pasteurizer was operating effectively, but they were concerned about whether the vending machine was being appropriately cleaned, whether there was enough water to clean the equipment, including the churns, enough hot water supply as well. They were concerned about movement of milk to the pasteurizer and then the movement of the pasteurized milk onto the machine. So the HACCP plan, the Hazard Analysis Critical Control Point plan, didn't cover the movement of milk from the pasteurizer to the vending machine. So they asked the farmer to deal with that. They also needed structural work to ensure the pasteurization room was a separate room, which could be fully cleansed and disinfected, and asked the farmer to ensure that there was an adequate hot water supply for cleaning the churn and equipment. So they had enough for washing hands, but they didn't have enough water for the industrial washing processes required. So the churn takes 110 litres of milk, so you get an idea of the size of it. So they need to have enough water supply in order to do that effectively. So the farmer took all this on board. Environmental Health carried out further visits and took more samples, the results of which were all satisfactory. So yeah, so that was a good outcome there. The farmer was keen to cooperate and to ensure that they met the required standards. So this is just to briefly mention some of the overall issues with farm vending machines. The farmer, sorry. There can be, when there's a farm vending machine, the farmer's selling the milk directly to the public, they need to register as a food business operator. And so some of them might not be aware they have to do that, and local authorities therefore might not be aware of the true numbers of these businesses operating in their area. They're often located in rural areas, and so some of them might go under the radar. There can be a difficulty for farmers in shifting their perception from farming to selling to the public. So the standards they have to meet are similar to those that would be required in a butcher's or an abattoir or a food processing factory, whereas it can be difficult for a farmer to move from a sort of farm mindset to that sort of level of cleanliness and hygiene requirements. There's an increasing number of them, so this machine was selling pasteurized milk, but there's a number throughout the country that are selling unpasteurized milk or raw drinking milk, which obviously carry their own set of risks as well. Repeatedly, Environmental Health have said that they often get poor Enterobacteriaceae results on sampling, and these are used as an indicator species, which indicate that hygiene measures are not up to standard. So they repeatedly get problems on different vending machines. There can be difficulties with cleaning, as I mentioned, with transporting the milk from the pasteurizer to the point of sale, and poor quality equipment, often it's second hand. Guidance and training for Environmental Health and also for the food business operators themselves. As I mentioned, sometimes it's the vending machine is a sideline really to farming activities. So the herd and the farm remain the farmer's main priority, and so it can be difficult to ensure that enough time and effort is put into the vending machine business, as well as maintaining all the routine input that's required on a farm. There's also an element of a lack of awareness that the milk that they can be selling is a potential health hazard if they've not been informed of that. So it's important they're aware of the potential risks to their customers. So public health bodies carried out some investigation across the southwest of England to see how many pasteurizers and milk vending machines there were registered, and across the southwest region there were 63 on-farm pasteurizers and 104 milk vending machines. So the Somerset had the highest level of on-farm pasteurizers, and Dorset had the most milk vending machines. So there's a bit of variation across the region as regards the distribution of these, as there is with gastrointestinal infections as well. they're apparently in the southwest of England, they generally have quite a high level of gastrointestinal infections in humans, not necessarily saying they're related to farm vending machines, but just in general across the country, that they do seem to have a higher level of GI disease. So further actions that will be taken by the public health bodies. So they're going to update the guidance notes for on-farm pasteurizers. There's a task and finish group that's been set up in the southwest, which are looking at inspection checklists for environmental health officers, provision of letters with information for the food business operator or the farmer themselves, so they're aware of the requirements and the standards which they need to meet. There's going to be increased liaison with the Food Standards Agency regarding the risks and communicating these risks, and then an overview report bringing all that information together. They're also looking at developing further training opportunities for environmental health officers and for food business operators, as I say, to let food business operators know what they need to do clearly, and to ensure that environmental health officers are fully trained and aware in order to ensure there's consistency across not just the region but across the country as regards licensing and approving these businesses. So that's that from me. If you've got any questions, I'm more than happy to take them. So thank you very much.